Perhaps I could best describe my experience of doing mathematics in terms of entering a dark mansion. One goes into the first room and it's dark, completely dark. One stumbles around, bumping into the furniture. And gradually you learn where each piece of furniture is. And finally, after 6 months or so, you find a light switch, you turn it on, and suddenly it's all illuminated. You can see exactly where you were. At the beginning of September, I was sitting here at this desk when suddenly, totally unexpectedly, I had this incredible revelation. It was the most important moment of my working life. Nothing I ever do again will. I'm sorry.
This is the story of one man's obsession with the world's greatest mathematical problem. For 7 years, Professor Andrew Wiles worked in complete secrecy, creating the calculation of the century. It was a calculation which brought him fame and regret.
So I came to this. I was a 10-year-old, and one day I happened to be looking in my local public library, and I found a book on math, and it told a bit about the history of this problem, that someone had resolved this problem 300 years ago. But no one had ever seen the proof. No one knew if there was a proof. And people ever since had looked for the proof. And here was a problem that I, a 10-year-old, could understand, that none of the great mathematicians in the past had been able to resolve. And from that moment, of course, I just tried to solve it myself. It was such a challenge, such a beautiful problem. This problem was Fermat's last theorem.
Pierre de Fermat was a 17th century French mathematician who made some of the greatest breakthroughs in the history of numbers. His inspiration came from studying the Arithmetica, an ancient Greek text.
Fermat owned a copy of this book, which is a book about numbers with lots of problems, which presumably Fermat tried to solve. He studied it, he wrote notes in the margins.
Fermat's original notes were lost, but they can still be read in a book published by his son. It was one of these notes that was Fermat's greatest legacy.
And this is the fantastic observation of Master Pierre de Fermat, which caused all the trouble. Cubem autem induas cubas.
This tiny note is the world's hardest mathematical problem. It's been unsolved for centuries, yet it begins with an equation so simple that children know it off by heart.
The square of the hypotenuse is equal to the sum of the squares of the other two sides.
Yeah, well, that's Pythagoras' theorem, isn't it? That's what we all did at school. So, Pythagoras' theorem, the clever thing about it is that it tells us when three numbers are the sides of a right-angled triangle. That happens just when x squared plus y squared equals z squared.
X squared plus y squared equals z squared. And you can ask, well, what are the whole number solutions of this equation? You quickly find there's a solution 3 squared plus 4 squared equals 5 squared. Another one is 5 squared plus 12 squared is 13 squared. And you go on looking and you find more and more. So then the natural question is, the question Fermat raised, supposing you change from squares, supposing you replace the 2 by 3, by 4, by 5, by 6, by any whole number n. And Fermat said simply that you'll never find any solutions. However far you look, you'll never find a solution.
You will never find numbers that fit this equation if n is greater than 2. That's what Fermat said, and what's more, he said he could prove it. In a moment of brilliance, he scribbled the following mysterious note.
Written in Latin, he says he has a truly wonderful proof, demonstrationem mirabilem, of this fact. And then the last words are, hanc marginis exiguitis non caperet. This margin is too small to contain it.
So Fermat said he had a proof, but he never said what it was.
Fermat made lots of marginal notes. People took them as challenges, and over the centuries, every single one of them has been disposed of, and the last one to be disposed of is this one. That's why it's called the last theorem.
Rediscovering Fermat's proof became the ultimate challenge, a challenge which would baffle mathematicians for the next 300 years.
Gauss, the greatest mathematician in the world.
Oh yeah, Galois.
Kummer, of course.
Well, in the 18th century, Euler didn't prove it.
Well, you know, there's only been the one woman, really.
Sophie Germain. No, there are millions of there are lots of people in there.